Let's talk about a really powerful way of thinking, one that helps us update what we believe when we see new evidence. We're going to break down how to think like a Bayesian, and we'll go from simple puzzles all the way to world-changing applications.
Okay, so let's jump right in with a fun little puzzle from the book Think Bayes. Picture this. You've got two bowls of cookies sitting in front of you. You have no idea which is which. You pick a bowl completely at random, you reach in without looking, and you pull out a vanilla cookie.
Now here's the catch. You know that bowl 1 is mostly vanilla, 3/4 vanilla to be exact, and bowl 2 is a perfect 50-50 split between vanilla and chocolate. So you're standing there holding a vanilla cookie. The big question is, which bowl is it more likely to have come from?
This is where things can feel a little tricky, right? Because it's super easy to say, oh, the probability of getting a vanilla cookie from bowl 1 is 75%. But that's not what we're asking. We want to know the probability that we chose bowl 1 given the fact that we're already holding a vanilla cookie. We have to kind of work backward from the evidence. And that right there, that's exactly the kind of problem Bayesian thinking was made for.
Okay, so the formal tool for this is a thing called Bayes' theorem. But don't worry, you don't need to be a math whiz to get the core idea. Let's just think of it as a simple, three-step recipe for updating our beliefs whenever we get new information.
So here it is, a super simple but really powerful loop. First, you start with a prior. That's just your initial hunch about something before you've seen any evidence. For our cookie problem, that was a 50-50 shot we picked either bowl. Second, you get some data, and that gives you the likelihood. Basically, how likely is this data if your hunch is right? Then you just combine your prior with that likelihood, and what you get is your new, updated posterior belief. It's just a formal way of learning from experience.
All right, let's take this recipe for a spin with another great example from Think Bayes. This time, it's M&Ms. We have two bags from two different years, and the mix of colors is different in each. We pull one M&M out of each bag. One turns out to be yellow, the other is green. Our job is to figure out which bag is from which year.
So, check this out. Here's our recipe laid out in a table. We start with our prior, right? A 50-50 shot for either hypothesis. But now, look at the likelihood. The probability of getting a yellow and a green M&M is just flat out higher if hypothesis A is true. And when we combine our initial 50-50 guess with this new evidence, bam, our belief shifts, and it shifts a lot. We end up with a posterior belief that there's a 74% chance that hypothesis A is the right one. The data just pulled us toward the most likely answer.
Now, you might be thinking this is all fun for solving little puzzles with candy, but this way of thinking is so much more than that. It's a seriously powerful tool for dealing with uncertainty, and it has had real, high-stakes consequences. It has literally changed the course of major historical events.
Let's go back in time to World War II. The Allied forces had a huge problem. They absolutely had to know how many tanks the Germans were churning out. Their entire strategy depended on it. If they got that number wrong, the consequences could be catastrophic. So they used their traditional intelligence methods, spies, reports, reconnaissance photos, and all of that intel was pointing to this enormous number. The estimates were coming in around 1,400 tanks per month, a truly terrifying number to be up against. But a group of statisticians tried something completely different. They looked at the serial numbers on captured German tanks and treated them like data points in a puzzle. Using Bayesian methods, they updated their estimate of total tank production. And their number was radically different. They estimated only about 250 tanks a month.
And here's the kicker. After the war, the Allies got a hold of the actual German production records. And the real number? 256 tanks per month. The statisticians, with just a handful of serial numbers, were almost perfectly correct. Meanwhile, all that conventional intelligence was off by a factor of 5. It's just an incredible example of the power of this approach.
But that was then. Today, with the insane amount of computing power we have, Bayesian analysis has really evolved. It's not just about these amazing one-off calculations like the tank problem anymore. It's become a whole iterative workflow, a constant loop of building, testing, and refining our understanding.
So the modern process, which you'll read about in books like Bayesian modeling and computation in Python, is really this cycle. You start by building a model, which is just a fancy word for a hypothesis about how the world works. You use data to make inferences and tune that model, but then, and this part is crucial, you check it. How well does it actually match reality? Could another model do better? It's this cycle of building, checking, and comparing that lets us constantly get better at understanding things. And that really gets to the heart of how this is done today. You don't try to build the perfect, super complex model right from the start. No way. You start with something simple. You see how it does against the data, and then you gradually, piece by piece, add complexity, letting each step teach you something for the next one.
So, why does all this matter to you? Well, at its core, Bayesian thinking is a framework for how to be smart when you're not sure about something. It teaches us that what we know isn't set in stone. It's always open to being updated. It gives us a structured way to blend our own expertise with hard data. And maybe most importantly, instead of giving a single, falsely confident answer, it honestly tells you the full range of possibilities. It quantifies uncertainty, and that's a huge deal.
This isn't just a mental model for scientists or data nerds. It's for anyone who wants to think more clearly about the world. It's a recipe for how to change your mind. And that really leaves us with one final thought, a question for you to take with you. What's a belief you hold right now that's just waiting for the right piece of new evidence to come along?